Okay, we're going to go over section 1.10. So the author talks about two types of representation. At the beginning of the section, the author talks about two systems or two clusters or clusters of the broadly defined um, two types of representation. You have the system world node that is roughly based on something grounded on something external, typically external factors, environmental conditions. So maybe I think this is kind of covering the the, the correspondence theory of truth, maybe to say that the statement the black the cat is white, right? So let's suppose that there is a statement called the cat is white. This statement is true if it corresponds to an actual cat in the world and that cat being white. So this system world node is broadly, I think, correspond to the correspondence theory of truth. And then what the author called the internal cognitive node or the internal cognitive cluster. And this is broadly this notion that there are these internal cognitive representations where token is taken as a representation in a inferential cognitive architecture. Now, so there's two different types of representation. There is the internal representation. There's the internal representation which is based on this internal cognitive architecture, and then there is the external node, system world node, where representation depends on things in the world. The author in this paper argues that the internal representation is a much more richer, more flexible tool for us. So after going over the difference between these two types of representations, the external system world type representation and internal cognitive node representation, the author go over more deeply on what this cognitive inferential architecture mean. And the author talks about three types of internal cognitive architecture. One such architecture is called the causal functional relation between, let's say, mental representations. Another is based on normative inferential relations or representations. Another is based on computational representation. And these three models are supposed to reflect different aspects of this cognitive inferential architecture that we have in our heads. And I think this is a big idea that the author talks about, is that the author is thinking that, or the author is arguing that this internal cognitive representation can be divorced with the external representation. So one can have these internal representation without regard to these external representation. So going back, the author talks about, and maybe going back to the beginning of this paper where the author talks about the matching game. In the matching game, you have a ledger. On the left hand side, you have statements. And then on the right hand side, you have facts about the world. The author described this view as the naive view. Instead, the author is saying that we should have a new category between the statements on the left hand side and the facts about the world on the right hand side. So this is in between the statements and the world is the models. So the models is what makes the statement true. So, for example, in this diagram right now, statements S1, S2, S3, they are true based on a model. But a model can be divorced with the facts about the world. So the authors say that the model and the world can be orthogonal to each other. That means that there need to be no link between the model and the world. Just to give some examples, right? Suppose that my statement, let's say S1 is a statement that the knight can attack up to 8 squares in the center of a chessboard. This statement is true by virtue of what? By virtue of the rules of chess. And the rules of chess would be my model. Okay. And in that regard, in that sense, the rules of chess doesn't need to have any connection with the world. But it is somewhat mysterious, say, if my statement were to be, let's say S2 were to be the statement that the helium atom has atomic number 2. Well, why is that statement true? Well, that statement is true by virtue of the model. And the model in question would be the rules of chemistry. So the rules of chemistry would be the model that give truth value to the statement that the helium atom has atomic number 2 is true. But the problem is that for most people, the rules of chemistry have some bearing with the world, right? Because what grounds the truth of chemistry for most scientific realists is because it's there. What grounds chemistry, the rules of chemistry, is because of facts about the world. But according to this author, he is saying that the rules of chemistry is orthogonal to the world, and as such, there is no connection between the rules of chemistry and the world. This is problematic, and I tend to disagree. Later on in the paper, the author talks about this thing called jigsaw puzzle, where we could think of the left hand side as statements, and we could group these statements into clusters. So you can have a clusters of statements, let's say the moral statements. We could group all the statements related to conditional probabilities statements. We could say define it by certain inferential uh, functional links between the statements, and that's what the condition is that say that these statements are part of one cluster. We could have relationship between clusters. So suppose that for this cluster is about conditional probabilistic statements, and suppose that we have this cluster is about belief and intentions. Maybe there is some general architecture where you could they could be part of a larger cluster. So you could have clusters, you have statements, you can have statements within clusters, and you can have relationship between clusters, like an architecture. So there's a relationship between statements within a cluster, and there is a relationship between clusters that are part of a larger cluster, and you can define that to be some sort of architecture. So I think the important thing about this section is that the author really is saying that these internal representation has no bearing on external representation. and that the coordinality of the things in the two sets need not be equal. So in the internal model, we have different types of representations: the rules of chess, the rules of chemistry, the rules of quantum physics. The world has their own facts about the world, and the number of elements in the model, in these internal models, need not be the number of facts there are in the world. So the coordinality between the two sets need not be equal. That's pretty much section 1.10. Thank you so much for listening.